Let's solve this question which has been asked in GATE 2019. We are given a main method. We are asked to find the output. We are asked to find the output of the given piece of code. Here the interesting thing is, it is an application of pointers and arrays. So this is the second program, or this is the second question that was asked in this year's GATE paper, in 2019 GATE paper on arrays and pointers. Goes to show how pointers are so important when it comes to C programming. In fact, it is the standout feature of the programming language, right? Every programming language, you take any programming language, it has a standout feature. For C programming, if you ask me, pointers are the standout features. For Java, object-oriented programming features, that is the standout point of Java programming, and so on. So without further ado, let's move on to solving this question. What we'll do is, as we always do, we'll examine the program step by step. We'll go line by line, we'll go really slow, we'll try to understand the nitty-gritties, and we'll ensure that at the end of this video, you are well acquainted with how arrays and pointers behave together. Now, in the first line, we find that there is an array initialization. It is an array of integers, as you can see from this data type of int. And here, what I'll do is, for your convenience, I will draw the memory layout of this array. By memory layout, what I mean is, I list out each and every element along with their indices in the array, as well as the memory location for every element. What will happen is, then you'll be able to understand how this program behaves even better. So my first array element is 2, the next one is 4, the third one is 6, the fourth one is 8, and the fifth one is 10. The indices are 0, 1, 2, 3, 4. The name of the array is A. Let's assign addresses to each of these array elements. Each of these array elements, as you probably must be knowing, is a variable. An array is a collection of variables. Since an array is a collection of variables and every variable is a named memory location, every array element will get a unique address. The first index, let's assume it has an address of 1000. And remember, I'm assuming int to take up 2 bytes here. If you assume int to take up 4 bytes and then go on to solve this question, you will get the exact answer that I will be getting. There will be no difference whatsoever. So the first address, that is 1000, next I'll get is 1002 because I've assumed int to be of 2 bytes. The third one will be 1004, 1006, followed by 1008 at the end. In the next line, I have a few declarations and initializations. But before I move on to the next line, what I must point out is the name of the array, which in this case is A, is a mnemonic for the base address. The name of the array is a mnemonic, for base address. What is the base address? The base address is the first address of the array. As you can see, this array consists of 5 elements or 5 variables, and the first variable here is at index 0. The address of this first variable is called the base address, and the name of the array is a mnemonic for the base address. The name of the array is a mnemonic. I keep on repeating this every time I take up a question on arrays and pointers. I make it a point to emphasize on this part that the name of the array is a mnemonic for base address, which also makes it a constant pointer. Why am I saying that it's a constant pointer? The name of the array is a constant pointer because it is a mnemonic for base address. That means it is simply a symbol or a symbolic representation for the base address, which is 1000, and any memory address that you take will be a constant pointer. Any memory address you take will be a constant pointer, and since the name of the array is simply a symbolic representation of the base address, which is a memory address, it is a constant pointer. That means we cannot carry out any arithmetic operations on this array name. We cannot carry out any multiplication or any addition or any division or any subtraction on this array name, because it is a pointer constant. It is not supposed to change during the execution of the program. I hope this is very clear to you. Now in the next line what we have is a declaration of the variable I. So the variable I has been declared. It still doesn't have any value. The variable sum has been declared with a value of 0. In fact, it has been initialized with a value of 0. And we have a pointer variable. Why am I saying it's a pointer variable? Because there is this asterisk before it, right? This pointer to operator. Here asterisk, mind you, asterisk behaves differently in different situations. If the asterisk is placed like this before a variable name, then it acts as a pointer to operator. If the asterisk is used, or if it is placed in between two variables, then it acts as a multiplication operator. And if the asterisk is used to extract value of a variable through a pointer, then it acts as a dereference operator. So we'll see how the asterisk behaves in different cases. Here, in fact, we'll get only two cases. The first one is here. It acts as a pointer to operator, and the dereferencing part will be seen here and here. Coming back to this variable b, it has been initialized with a value of a plus 4. This value of a plus 4 can be misleading. Why? Because, mind you, what did I assume? I assumed the size of the array to be of 2 bytes. I'm extremely sorry. I assumed the size of int to be 2 bytes. So when I say a plus 4, I do not mean that you take the value of a, which in this case is 1000, and add 4 to it directly. No, that is not how it works. What will happen is, in case of pointers, in case of pointer variables, it is always a case of scaled arithmetic. It is always a case of scaled arithmetic. Scaled arithmetic. We always have to take into account the size of the variable, or the size of the data type of the variable to which the pointer is pointing to. What is the size of the variable to which, or size of the data type of the variable to which this pointer is pointing to? Its size is 2 bytes. Why? Because it is an array of integers, and I've assumed every integer to take up 2 bytes. So when I say a plus 4, what I get is 1000 plus size of int, which in this case is 2, multiplied by this value of 4. So this comes out to be 1008. Now b, which is a pointer variable, will hold a value of 1008 quite rightly, because that is what pointers are for, in order to store memory addresses. Pointers are used to store only and only memory addresses. Pointers cannot store values of variables. We can access the variable, or we can access the value of a variable through a pointer, but we cannot store the value of that variable inside a pointer. We can store the address of the variable inside the pointer, and through that address we can access the value of the variable. In the next line we have a for statement where there is an initialization part. I gets a value of 0. Initialization always is carried out exactly once in a for statement. Next we have the test condition. As we can see, 0 is less than 5, which is true. Since this condition is satisfied, we entered the body of the loop. The body of the loop is telling us that an operation has to be carried out in this fashion. Take the value of sum, which in this case is 0, and add it with these two quantities. Let's evaluate this quantity first. What am I doing? I'm doing star b. Here, this star is acting as the dereference operator. That means the value of b is what? 1008. 1008 means I'm standing here, outside. At this point, outside this cell, I'm standing here because this cell has an address of 1008, so I'm standing here. If I do star, I'll be dereferencing this memory cell. By dereferencing, what I mean is I'll get inside this cell, and if I get inside this cell, what I get is a value of 10. So in place of star b, I'll be getting a value of 10, and if I subtract the value of I, which in this case is 0, from 10, I get 10 itself. So this part is now 10. Now the value of sum, it's going to change. How is it going to change? We are going to get a value of sum equal to 0 plus 10 we are going to get a value of sum equal to 0 plus 10 minus, see, now the dereferencing part will take place on this entire value of b minus 1. There's a difference, right? Here the dereferencing took place on the value b. Now the dereferencing will take place on this entire value of b minus I. What is the value of b? The value of b is 1008. Now if I do minus I, what is the value of I? The value of I is 0. Mind you, again, it will be a case of scaled arithmetic. That means I'll have to do the value of b, which is 1008, minus the value of I, which is 0, into the scale factor. The scale factor is the size of int, which in this case is 2. So 0 into 2 will come out to be 0, and 1008 when subtracted from when 0 is subtracted from 1008, we get 1008 itself. So, and after I get b minus I to be 1008, I'll have to dereference it. And if I dereference it, what is the value that I'll get? I'll get a value of 10 itself. That means here what will happen is I'll add and then again subtract 10, giving an effective value of 0 again. So here I get a value of 0 once again. Now this, as you can see, this for loop has only one statement associated with it. This is a single line for loop. That's why, see, if you had curly braces, then this and this curly brace had ended over here, then this printf could have been part of the for loop. Since there are no curly braces, this single statement, this one statement of incrementing the value of sum is only considered to be part of the loop. After this, we go on to the updation part where the value of I is incremented from 0 to 1, and we'll check, yes, I is less than 5 because 1 is less than 5, which takes us inside the body of the loop where we find the value of sum to change. Let's see how it's going to change. The value of sum, see here, sum is currently 0 plus, now see what happens, star b minus I. What is the value of b? The value of b hasn't changed. It's still 1008. If I do star b, I'll be dereferencing this memory location. I'll be getting inside and getting the value of 10. And if I subtract the value of I, which happens to be 1 right now, I'll get 9. And then what I'll do is I'll minus, what will I minus? I'll minus star b minus I. What is the value of b here? The value of b is not going to change. As you can see, there is no statement which will change the value of b. So it remains to be 1008. And now we are going to do 1008 minus the value of I, which is 1 in this case, into the scale factor of 2. Now 1008 minus 1 into 2 is 2, that is 1006. So now I'll be dereferencing the location 1006, which is 8. So I'll get 8 here. See, this came out to be 1006. This part, b minus I, came out to be 1006. So I'm standing here. I'm dereferencing it to get this value of 8. So I'll get 8 in place of this entire expression. 9 minus 8 comes out to be 1. Finally, the value of sum has been incremented to 1. Again, we are taken to the updation part where the value of I changes to 2. We check this condition which evaluates to be true. We come inside the loop. Again, we'll see star b minus I. Star b minus I means what? What is the value of b? 1008. So we dereference it. We get a value of 10. How will the value of sum change now? We have an initial value of 1. See, sum is currently 1. So I'll substitute 1 in its place. I'm doing star b. What is star b? Star b is going to be 10 minus, so I'll get 10 minus I. What is the value of I? The value of I is 2. So I'll directly write it. 10 minus 2 is 8. 10 minus 2 is 8 minus star of b minus I. I think you have got the trick now. What is the value of b? The value of b is 8. Now if I do 8 minus I, I'll have to do 8 minus I into 2. The value of I is 2. So 2 into 2 is 4. 1008 minus 4 will give me 1004. So 1004 means I'm standing over here. If I dereference it, I get 6. So it's 1 plus 8 minus 6. 8 minus 6 will give me 2, and 2 plus 1 will give me a value of 3. Again, the value of I will be incremented. We'll go to the updation part. We'll increment the value of I to 3. The condition evaluates to be true, and we are again led to the body of the loop. The body of the loop will execute in this way. The value of sum, which is currently 3, to the value of 3, what I'll do is the value of 3, I'll add. What will I add? I'll do star b. Star b again will give me 10. And the value of I is currently how much? The value of I currently is 3. So 10 minus 3 will give me a value of 7 minus star of b minus I. B is 1008. 1008 minus the value of I, which is 3. That means 3 into 2, which is 6. So 1008 minus 6 will give me 1002. So I'm standing here. I'll dereference it using this asterisk and I'll get a value of 4. So if I get a value of 4, I am left with 3 plus 7, 10. 10 minus 4, 6. Again, one final time, the loop will execute. I will become 4. Now 4 is less than 5, so condition is satisfied. You enter the body of the loop. You enter the body of the loop. And what you get is, you get the expression for sum. So how will sum behave? The value of it, which is 6, will be copied here. See, sum is currently 6. So this comes here. Plus star b minus I. What is b? B is 1008. So if I do star, I get 10. 10 minus the value of I. The value of I is 4. So 10 minus 4 will give me 6 minus star of b minus I. So first I have to evaluate this value of b minus I. B is 1008. I is 4. That means 4 into 2, which comes out to be 8. So 1008 minus 8 will give me 1000. That means I'm standing here. If I dereference it using this asterisk, I get inside to get a value of 2. So if I subtract 2 from it, I'll get a value of 10 for sum. After I get a value of 10 for sum, again I'll go back to the updation part where the value of I will be incremented to 5. And if I check now this test condition, 5 is not less than 5. So the condition is evaluated to be false. That means I'll come out of the loop, and in the first statement outside the loop, I find a printf statement where I'm printing the value of sum. And what is the value of sum? The value of sum has come out to be 10. And what were we asked? We were asked to find the output of the above program. We got only one value for the output, which is the value of sum, which has come to be 10. That means the output of the above C program is 10. I hope this helps. Thank you.